Okay, so what we're going to do is check for self-resonance of a RF choke that is homemade here. This was originally a 100 microhenry choke from Radio Shack, and somewhere on the web I found a reference to them having a self-resonance, series resonance condition, and that could be eliminated by removing the outer turns on the coil to where it's just a single layer of coil, and that ends up being about a 50 microhenry coil. So what we've done here, sweep up to the radio here, going to use the old Kenwood TS430 as a signal generator, low power, maybe 5 to 20 watt signal generator. So it's got a cable coming out its RF section and going down to the dummy load in this MFJ antenna tuner. Now in parallel with the dummy load we have a couple of alligator clips here, and basically I've wired up through this mess of alligator clips a flashlight light bulb just in parallel, and it's hard to see. I'm using a resistor just as a place to clip on there. I soldered a resistor lead onto there. So what happens is if I transmit with the radio, I can turn up the power a little bit, and you can see that the bulb starts glowing at just a couple watts. So I can increase that a little bit too much there. So then if I look at the oscilloscope, I can see that I have about one division at 10 volts per division, so about 10 volts peak to peak will make the light bulb about that bright. Let me turn off the power here. That looks really bright, but it's not as bright in real life. So I'll turn off the RF generator here, and I'll hook up the choke in series with it. So now we've got this choke in series with the light bulb, and again I can turn on the RF from the radio, and you can see on the scope that we've got at least one division there, so that's a good thing. Now if I just start turning the frequency on the radio up a little bit at a time, and then watch the light bulb here as I do that, and we can see we're not getting any light bulb glowing yet. I'm at 3.7 megahertz right now and moving up, and the scope is staying well above the 1 volt or the 10 volts. So we've got plenty of power going into the dummy load, and no power is being coupled through the RF choke to the light bulb, so that's a good thing. That indicates that there's no series resonance. I'm continuing to go up. I'm about 8.2 megahertz now, and just keep moving up. And I'm looking for that light bulb to glow at any point here. Now we're about 12, 13 megahertz. Still nothing. Continuing to sweep up in frequency. The reason I'm doing this is that the original choke that I had in my in my base matching network for my 43-foot vertical at some point shorted out when I was putting everything together. All the turns just basically melted and shorted together, and that caused quite a problem. And I was never able to get the matching network to work. So after fixing all the other problems, just in case, I'm checking to make sure that the choke doesn't have some series resonance where it would pass a whole bunch of RF power through to the DC circuit that I'm trying to pass through without passing the RF through. I'm at 26 megahertz and still sweeping up. Still have well above the 1 division. Looks like we've got probably close to 5 watts out here into the dummy load. 28 megahertz, still sweeping up. And there we're at 30. So we didn't see the light bulb come on at all during all of that. So now, just to test the theory and make sure that that's working as we expect, I'm going to put a 30 picofarad capacitor in series with it. And what that'll do is it should make a series resonant circuit at around somewhere 4 or 5 megs, depending on the stray capacitance that's involved. So I'm going to turn this off and hook that up, and then we'll try it again.